Hello dear students, I welcome you all to another session of online class on straight lines. Okay, so the topic for the day is very important. Okay, so from here onwards it's going to be like a linked chain. That means if you don't understand one topic, okay, then the very next topic it's going to be very difficult for you to understand. Okay, so I request you to pay attention to what is being taught here, okay, so that you will be able to apply whatever you have understood in the sums which are given in your exercise. Okay, so the first topic for the day is slope of a line. Okay, so we are going to learn what is slope of a line. Okay, so in order to understand this particular topic, let me take our xy coordinate system. So this is my xy coordinate system, x-axis, origin, and this is my y-axis. All right, and here I am going to draw a straight line since the topic is talking about a line. Okay, so here suppose if I draw this line, okay, so I have drawn this line and let me call the line to be L. Okay, now here we need to measure the angle made by this line with x-axis. Okay, now if you see here, there are two angles being formed. One is this angle, right, and another is this angle, right. So basically this straight line is making two angles with the x-axis, okay, and we have to choose any one of them. Okay, and here in order to find the slope of a line, we have to choose the angle formed with the positive direction of x-axis. For example, this is my line, right? Now if you see here, whenever you go to the right side, then only you will get positive. If you come to the left, then you will have negative sign, isn't it? So that's why this angle, okay, so this angle is in the negative direction. All right, so that's why you have to go to the positive direction of x-axis, and that angle is this one. All right, so you have to always look for this angle when you find slope of a line. Okay, and let me call this angle to be angle theta. Okay, and this theta is called inclination of the line. Okay, now if theta is the inclination, then what is slope? That's what we are going to understand. Okay, and slope of a line is always denoted by small m. Okay, so whenever you see small m, that means that is the slope of a line. Okay, and you have already come across one of the very famous equation of a line in your class 10, that is y equals to mx plus c, right? Now here this m stands for the slope of the line. Okay, and how do we define slope of a line? Now the definition of slope is very simple. Okay, so slope, that is m, is defined as tan of this inclination. Okay, so whenever you see tan theta, that tan theta gives you the slope of a line. Okay, so this is one of the very important property or definition of slope of a line. Okay, now for example, if in your question, if somebody is giving you, if the angle of inclination, that is theta, is equals to 45 degree, then what will be the slope of the line? If the question is asking this way, then you just need to put the value of theta to be 45, and tan 45, we all know that the value of tan 45 is 1. Okay, so the slope of the line becomes tan 45. Okay, now the next very important formula. See, all these are your formula, so I expect you to note down these formula in your diary. Okay, so this is our first formula. Now the second formula for calculating slope, okay, slope of a line. Suppose, imagine that you are not given theta. Okay, if you are given theta, then only you are able to calculate m, isn't it? But if you are not given theta, then how do you calculate? So that time, if theta is not given to you, then two coordinates has to be given through which the line is passing. For example, if I am taking this coordinate, okay, let me call this as x1, y1, okay, and let me take this, okay, this coordinate x2, y2. Okay, so if you see here, this line, straight line, passes through 2 points. One is x1, y1, and another is x2, y2. Okay, so if these two things are given to you, the points through which the straight line passes, then the slope of the line is calculated using this particular formula. So the formula is y2 minus y1 whole divided by x2 minus x1. Alright, so these are the very important formula for calculating slope of a line. So there are two formulas that you need to remember here. Okay, now if this is the case, then I am going to give you some special case. Okay, so case 1. Okay, I am going to ask you what is the slope of x-axis. Okay, so case 1 is slope of x-axis. Now we know that x-axis, this line is also what? This is also a straight line. That means it is also having one slope, right? Now if you see here, let me erase this straight line. I am interested only with x-axis. So this is my x-axis and I am going to find what is the slope of this. Now in order to find slope, what do we need? We need the value of theta, that is inclination. Now if I ask you, how much angle is this line making with the positive direction of x-axis? You will say obviously it is 0, isn't it? Because it is not making any angle, no. So that's why it has to be 0. So that's why in this case theta, angle of inclination, is 0. So that's why my slope will be tan 0 degree. And what is the value of tan 0? We all know that the value of tan 0 degree is 0. That means the slope of x-axis will always be equals to 0. So this is our case 1. Okay, so next is case 2. So in case 2, I'm going to take what is the slope of this line, that is y-axis. Okay, so slope of y-axis will be equals to, okay, now let us see how much angle does this line makes with the positive direction of x-axis. Okay, so obviously this angle is how much? 90 degree, right? So in this case my theta is 90 degree, right? And what is the value of tan 90? We all know that the value of tan 90 degree is undefined, right? So that's why we see the value is infinity out here. Okay, so these are the very important cases that you need to remember, which you might get in your objective as well. All right, so these are the very important things that you need to note, and you will note down these in your diary. All right, okay, so the next thing that we are going to learn here is something called angle between two straight lines. Okay, angle of intersection between two straight lines. Okay, so suppose, imagine, okay, let me write topic for the day. So angle between two lines. Okay, so if you see here, this is one line, this is another line. Okay, so here there is one angle being formed here. Okay, so let me call this to be theta. Okay, and we want to find the value of this theta because this is the angle of inclination. Now most of you might be saying, sir, we have got this also the angle of inclination, isn't it? Okay, so if you are able to find this one of the angle, then other one is very simple, right? Just subtract this angle. Suppose if this theta is 60, then this full angle is 180, isn't it? So if this is 60, then this has to be automatically 120, right? So it's very simple to find the other angle. So we will try to find only this angle. Okay, so basically we will find the acute angle, that is the angle less than 90 degree, and the obtuse angle will come automatically. Okay, so the angle between two straight lines, okay, that is theta, is calculated using this particular formula. So just imagine that the slope of this line is m1, okay, and the slope of this line is m2. Fine. Okay, so if m1 and m2 are the slopes of two straight lines being intersected, okay, then the angle of inclination is calculated using this formula. Okay, so the angle of inclination, that is tan theta, this theta we need to find, okay, will be equals to modulus. So modulus means absolute value, so we are taking only positive value here. Okay, so it will be m1 minus m2 by 1 plus m1 m2. Okay, so I hope you are clear with the modulus sign, because this theta is acute angle. Okay, and we know that the value of acute angle, okay, tan of acute angle, that means 0 to 90 degree. If you take tan of any angle in between 0 to 90 degree, that will always be positive. So that's why in order to make this value positive, I am putting modulus sign here. Okay, very good. So the next thing, again we will go to some special cases out here, and the first case, okay, so let me call this as case 1. Okay, so I am going to find angle between, okay, so, or condition for two lines to be parallel. So this means when does the two lines will be parallel. So that's what I am going to find here. Okay, so suppose if I take two lines parallel to each other, and I am asking you here, what is the angle of intersection between these two lines? Now, do these two lines intersect each other? No, right? Okay, so that's why I can say that the angle of intersection between them is 0 degree. Okay, so basically here the value of theta, that is angle of intersection, is 0, right? So my theta is 0 degree, right? So if I use this formula, then I have, okay, so we have tan theta, that is 0 degree, equals to, this is m1 minus m2 by 1 plus m1 m2, right? Okay, and as I said, we have to make it positive, so that's why I am putting modulus sign out here. And how much is tan 0? Tan 0 is 0, right? So if this is my 0, okay, so this full thing is positive, right? And this full thing is becoming 0, so I need not put modulus sign here, isn't it? So we have m1 minus m2 by 1 plus m1 m2. Now let's do the cross multiplication out here. Okay, so 0 into this becomes how much? So this is 0 itself, so we have m1 minus m2 here. Okay, and if I take m2 out here, this becomes m1 equals to m2, right? So m1 is equals to m2. Now this is the condition for two lines to be parallel. That means if the two lines are having same slopes, m1 and m2, they are the slopes of two different lines. Okay, so if the slopes are equal for two different straight lines, then those two straight lines will be parallel to each other. Okay, so the case 1 is clear to you, right? Now similarly, I want you to find what is the condition for two lines to be perpendicular. That means what happens if this theta will be equals to 90 degree, angle of intersection between two lines has to be 90 degree if they are perpendicular to each other. Okay, so let me do it for you. I don't know whether you will be able to do this or not. I'll just show you quickly here. Okay, so we have case 2, right? So in case 2, I'm checking condition for two lines to be perpendicular. Okay, so here what is happening to theta? Theta is equals to 0 degree, right? Okay, so therefore this formula changes into tan, okay, I'm sorry, tan theta is 90 degree, so 90 degree equals to m1 minus m2 by 1 plus m1 m2. Again we know that the value in between 0 to 90 degree will always be positive, so that's why I'm not putting modulus sign out here. Okay, and we know that tan 90 degree can be written as sine 90 degree by cos 90 degree equals to m1 minus m2 by 1 plus m1 m2. Okay, let us put the value. So sine 90 degree is always 1 and cos 90 degree is 0, so minus m2 by 1 plus m1 m2. Let us do the cross multiplication. So 1 into this quantity remains as it is. So 1 plus m1 m2 equals to 0 into any number will be 0. So from here what am I saying? I am saying that m1 m2 is equals to, this 1 goes over there, becomes minus 1, isn't it? So the condition for two lines to be perpendicular is given out here. That is, the product of the slopes has to be equals to minus 1. Then only the lines will be perpendicular to each other. Okay, so hope the conditions are clear to you. Okay, so if you have understood this much, then we are ready for our problems on exercise 11.4. Okay, so let me take the first question. So in the question it is said that show that the line joining 2 comma 3 minus 3 and minus 5 comma 1, okay, so there is a line joining these 2 points, is number 1 parallel to the line joining 7 comma minus 1 and 0 comma 3. Okay, so let us quickly note down what are the things given. So it is question number 1. The given points are okay, so let me write it as P and Q. Okay, so P is given to be 2 comma minus 3, okay, and minus 5 comma 1. Okay, so let me call this as point Q. Okay, so these two are the given points, and through these 2 points there is a line passing. Okay, so the case is somewhat like this. So this is the line. Okay, so this is my point P and this is my point Q. So I can call this line to be line PQ. Yes. Okay, so we need to show that this line is parallel to some other line. So basically we know that the lines will be parallel if and only if their slopes are equal to each other. So basically here we need to find the slope of the line passing through P and Q, right? So that's why let me firstly write the slope of the line PQ. Okay, so therefore m of PQ, so this means slope of line PQ. Okay, and we know that if this is my x1 y1 x2 y2 x1 y1 and x2 y2, then the slope formula is y2 minus y1. So y2 is 1 minus y1 is minus 3. Okay, x2 minus x1 is 2. Okay, let us simplify this. So this is 1 plus 3. Okay, so this is minus 7, isn't it? So this is equals to minus 4 by 7. So this is my slope of this particular line. Okay, now in the sub number 1, we have been given 2 points. Okay, so the given points are, so let me write it as A and B. Okay, so A, that is 7 comma minus 1, and B, that is 0 comma 3. Okay, so we need to show that the line passing through A and B is parallel to this particular line. Okay, so the case is going to be somewhat like this here. Okay, so again we have founded the slope of PQ. Let us similarly find the slope of AB. If the slopes turns out to be equal, then the lines has to be parallel to each other. Okay, so we have therefore m of line AB, slope of AB, right? So again this is my x1 y1 x2 y2. So the formula says y2 minus y1 is minus 1, yes, and x2 minus x1. Okay, so we have, okay, so this is 3 plus 1 by, how much is this? This is minus 7, and how much is this? So 3 plus 1 is 4, so it is minus 4 by 7. So here we clearly see that this and this, the slope of both the lines turns out to be equal, right? Now since m of PQ is equals to m of AB, we say that PQ and AB are parallel to each other. Okay, hence PQ is parallel to AB. All right, so that's what we need to show in our first case. Okay, let us see the second case. So in second case, we need to show that the line passing through two given points is going to be parallel to PQ. Okay, so in number 2, let me write. Okay, so the given points are okay, so what are the given points? So one is 4, 5. So let me write as x 4, 5 and y. So let me write y to be 0, -2. Okay, so again let me find what is the slope of xy. Okay, so therefore slope of xy turns out to be, so again we know that the formula is y2 minus y1, y2 is -2 minus y1 is 5 divided by x2, x2 is 0 minus x1, x1 is 4, right? Okay, so we have, this is -2 minus 5 is -7 and this is -4. So how much is this? These two gets cancelled and this is 7/4. Now we know that the condition for two lines to be perpendicular to each other is the product of the slope has to be -1. Okay, so let us find the product of line slope of line PQ and slope of line XY. Okay, so therefore m of PQ into m of XY. So let us find this. So how much is m of PQ? So we know that this is -4/7 into what is m of XY? It is 7/4. So 7 and 7 gets cancelled, 4 and 4 gets cancelled. So how much is left? It is -1. That means the product of the slopes is turning out to be -1. So therefore PQ will be perpendicular to XY. So that's what we need to show. Alright, so you may pause the video to note down. Okay, so let me take question number 3 for you. So question says, find the value of x so that the line through x, 9 and 2, 7 is parallel to the line through 2, -2 and 6, 4. Okay, so there are two lines being parallel. Okay, so this line passes through x, 9, okay, and 2, 7. Okay, and similarly the other line passes through 2, -2 and 6, 4. Okay, so you need to find the value of x here. So again, since these two lines are parallel to each other, what happens here? The lines will have equal slope. Alright, okay, so the given points are, so let me write, this is question number 3, the given points are, okay, so let me write this A, B, C and D. Okay, so A, that is x, 9, B, that is 2, 7, C, that is 2, -2 and D, that is 6, 4. Okay, so you can make this diagram in the side of your page as well. Okay, so according to question line, okay, so this is my A and B, so I can say AB is parallel to what? Line CD, right? And we know that the lines will be parallel to each other if, okay, if slope of one line will be another slope of another line, right? So that's what we have understood. Now let us find what is the slope of AB. So this is my x1 y1, this is my x2 y2. So my formula is y2 minus y1, that is 7 minus 9, yes, so 7 minus 9 divided by x2 minus x1, that is 2 minus x, equals to, let us find what is the slope of C and D, okay, CD. So we have x2 minus x1, that is 4, I'm sorry, y2 minus y1, y2 minus y1 is minus 2 divided by x2 minus x1 is 2. Okay, so let us quickly simplify this and find the value of x from here. So we have 7 minus 9 minus 2 minus x equals 2. So this is 4 plus 2 and this is 4. Okay, so let us do the cross multiplication. So how much is this? This is 6, right? So 6. Okay, so let us do the cross multiplication this way. So minus 2 into 4 is minus 8 equals to this 6, right? 6 to the 12. Okay, so minus 6 into x is 6x. Get this x out here and take this 8 over there. Okay, so we have 6x equals to 12 plus 8, which is equals to how much? 20, right? So therefore from here x turns out to be 20 by 6. Okay, so do the cancellation with 2. So 2 3s are 6, 2 10s are 20. So the answer, that is the value of x, turns out to be 10 by 3. Alright, so you may pause the video to note down. Okay, so let me take question number 8 for you. So question 8 says, find the angle between the lines joining 0, 0, 2, 3 and 2, minus 2, 3, 5. Okay, so basically here we have been given two lines, okay, and we need to find the angle of intersection between the lines, and one of the line passes through 0, 0 and 2, 3. Okay, and the other line passes through the point 2, minus 2 and 3, 5. Okay, so we need to find what is the angle of intersection between the lines, and the formula for calculating angle of intersection is tan theta equals to modulus of m1 minus m2 whole divided by 1 plus m1 m2. So basically in order to calculate that theta, what do we need? We need the value of m1 and m2, that is the slope of two straight lines. Okay, and since the points are given to us, we will be able to calculate what are their slopes. Okay, so for line 1, okay, which passes through, so which passes through, okay, so the question number is 8. Okay, so this is question number 8. So for line 1, which passes through, so let me call this to be line 1 and let me call this to be line 2. So line 1 passes through 0, 0, okay, and 2, 3. Okay, so for line 1 which passes through 0, 0 and 2, 3, the slope is given by m1. Okay, so the slope m1 will be equals to again y2 minus y1, right? So y2 minus y1, that is 3 minus 0 by 2 minus 0. Okay, so this is equals to 3 by 2. So the slope of this particular line is 3 by 2. Okay, now let us see what is the slope of line 2. Okay, so for line 2, which passes through, okay, so the line 2 passes through 2, minus 2 and 3, 5. Okay, the slope is given by, okay, so it is given by m2. Okay, so m2 will be equals to y2 minus y1, that is 5 minus of minus 2, okay, divided by x2. x2 is 3 minus x1. x1 is 2. Okay, and how much is this? So let us see. So this is 5 plus 2 divided by 1, which is equals to 7. That means the slope of second line is given to be 7 here. Okay, so let us find the angle of intersection. Okay, so therefore tan theta is equals to, we know that it is m1 minus m2 by 1 plus m1 m2. Yes, so this is the formula. So let us calculate the value of theta here. Okay, so from here we have m1. How much is m1? So m1 is equals to 3 by 2. So 3 by 2 minus m2. m2 is 7 divided by 1 plus 3 by 2 into m2, that is 7. Okay, so let us quickly evaluate this. So we have, so 3 minus, okay, 3, 2, 7 is 14, right, by 2 divided by, okay, so this is 2 plus 3 7s are 21 by 2. I hope you know how to simplify this. Okay, so this 2 and 2 gets cancelled. So basically this is equals to, okay, so we have, okay, so 14 minus, see, the sign is opposite, so that's why it will be, so we need to subtract. So 14 minus 3 is 11, but the sign will be minus, so minus 11 by, how much is this? This is 23, right? And since we are taking modulus, my value will be equals to 11 by 23. Okay, so therefore tan theta is equals to 11 by 23. Okay, so from here I don't have space, so you are asked to find theta, right? So you need to remember one thing. So if you want, suppose here we have tan theta equals to 11 by 23. Suppose if you are asked to find the angle of intersection, that is theta, then this tan goes over there and becomes tan inverse. Okay, so you need to remember this. This is called inverse trigonometric functions, which you will learn in your class 12. Okay, but this thing you need to remember here itself. Okay, so this tan goes over there and becomes tan inverse 11 by 23. All right, so that's why your answer for this particular question is going to be tan inverse 11 by 23. All right, so you may pause the video to note down. Okay, so let me take question number 10. So question says, without using Pythagoras theorem, show that the points minus 2 comma 2, 8 comma 2, sorry, 8 comma minus 2 and minus 4 comma minus 3. Okay, so they are the vertices of a right angled triangle. So basically here in your junior classes, if you were asked to solve this, okay, if you are asked to solve this, then what you used to do is you used to find length of each, right, and you used to apply Pythagoras theorem in order to show that the vertices are, the points are the vertices of a right angle triangle. So that's how you did in your junior classes. But here you will not do the same. If you do that way, then you will lose marks in exams. All right, so here the process is, see, we know that this is 90 degree. That means this side and this side, okay, or this line and this line are perpendicular to each other, right? And we know that the rule for two lines to be perpendicular is the product of this line, the slope of this line and this line has to be equals to minus 1. All right, so basically what you're going to do is you will first find the slope of each side here. Okay, so if I call this as A, B and C, so basically, okay, so suppose if this is my A, B, C, then find the slope of AB, BC and CA. Okay, and find two slopes whose product is going to be minus 1. All right, so that's all you need to do here. Okay, so if you show that the product of two slopes is becoming minus 1, then those two sides have to be perpendicular to each other and automatically the triangle becomes right angled triangle for you. Okay, so the given points are, so this is my question number 10. So the given okay, so let us quickly find the slope of AB, BC and CA. Okay, so therefore slope of AB will be equals to y2 minus y1. So y2 is minus 2 minus y1 is 2 divided by x2 minus x1. Okay, simplify this. So this is minus 4. So again this is going to be minus into minus is plus. So 8 plus 2 is going to be 10. So this is going to be minus 2 by 5. Right, Okay, so similarly let us find what is slope of BC. So slope of BC will be equals to again y2 minus y1, y2 minus y1 divided by x2 minus 4 minus x1. x1 is 8. So let us see this. So this is minus 3 plus 2 divided by minus 12, right? Okay, so this is equals to minus 1 by minus 12. So minus and minus gets cancelled. So this is 1 by 12, right? So as I said, we need to search for two pairs of slopes whose product is going to be minus 1. So let us multiply these two slopes. Will I get minus 1? No chance, right? So we are not getting minus 1. So we need not multiply these two. Okay, so at last we have m of CA. Okay, so this is my x1 y1, x2 y2. Okay, so we have x2 minus x, y2 minus y1. So minus 3 minus 2 divided by x2 minus x1. x1 is minus 2. Okay, simplify this. So this is minus 5. Okay, so minus into minus plus 2, right? So minus 4 plus 2 is minus 2. So these two gets cancelled and it becomes 5 by 2. Now if I ask you to choose two pair of slopes whose product is going to be minus 1, then obviously your choice will be m of AB and m of CA, isn't it? Because I think the product of these two is going to be minus 1. How? Let us see. Okay, so we have m of AB into m of CA, right? m of CA equals to, what is m of AB? It is minus 2 by 5 into what is m of CA? It is 5 by 2. So if you see here, this 2 gets cancelled and we have minus 1. Okay, so therefore AB is perpendicular to CA, which means one of the angle is 90 degree here, right? Okay, which means that triangle ABC is a right angled triangle. Alright, so you may pause the video to note down. Okay, so let me take question number 11 for you. So let me read the question. So if A, that is 2 minus 3, and B, that is 3 5, are two vertices of a rectangle ABCD. So there's a rectangle ABCD, okay, so where the coordinates of A and B are given to you. Okay, so find the slope of BC. So you need to find what is the slope of BC, you need to find what is the slope of CD, and you need to find what is the slope of DA. Alright, and here in this case, in the rectangle, we know that opposite pairs of lines are parallel to each other. That means AB is parallel to DC, and I can say that DA and BC, they are parallel. Alright, so basically we have been given the slope of A and B. I'm sorry, the coordinates of A and B. That means, can we find the slope of line AB? Yes. Okay, and we know that the parallel lines will have equal slopes. So that's why the slope of DC will also be equal to the slope of AB. Okay, and one more thing that we know is this is going to be perpendicular, right? So in a rectangle, BC and AB will be parallel to each other. So definitely if we know the slope of this, we'll be able to find what is the slope of this. Okay, and once we are done with the slope of this, then how much ever is the slope of this, DA will also have the same slope, as DA and BC are parallel to each other. Alright, okay, so let us find what is the slope of AB. Okay, so first let me write this question number 11. So in rectangle ABCD, okay, so in rectangle ABCD we have, as I said, AB will be parallel to BC, yes, and what is parallel to this? So BC is parallel to AD. Okay, so BC is parallel to AD. So these two things are there. Also we say that BC is perpendicular to AB, right? So BC is perpendicular to AB. So these are the main things that we need in this particular question. Okay, given points are A, that is 2 comma minus 3, and B, that is 3 comma 5. Okay, so let us find what is the slope of AB. Okay, so therefore slope of AB will be equals to, okay, so this is again y2 minus y1, so 5 minus of minus 3 divided by x2, that is 3 minus x1. Okay, so let us quickly calculate this. So this is 5 minus into minus is plus, so 5 plus 3 is 8 by 3 minus 2 is 1. So the slope of AB is equals to 8. Okay, so automatically the slope of DC will be equals to 8, right? So therefore slope of DC, okay, so slope of DC will be equals to slope of AB. Why? Since DC is parallel to AB, okay, and this is equals to 8. Okay, so this is my one of the answer. Now since, okay, so also the slope of AB into slope of BC, okay, slope of AB into slope of BC will be equals to how much? Minus 1. Why? Because since AB is perpendicular to BC, right, or BC is perpendicular to AB. Alright, so let us put the values out here. So what is the slope of AB? Slope of AB is equals to 8 into, we need to find slope of BC equals to minus 1. So from here the slope of BC turns out to be minus, this 8 goes over there, becomes this much, right? So this is my another answer. So this is my slope of DC. So this is my one of the answer. This is my another answer. Okay, and at last we need to find what is the slope of AD, right? So we have therefore slope of AD, and we know that AD is parallel to BC, right? So that's why we have this, right? Since AD is parallel to BC. Okay, so what is the slope of BC? We know that slope of BC just now turned out to be how much? Minus 1 by 8. So that's why the slope of AD will also be minus 1 by 8. Alright, so you may pause the video to note down. So let's see the 13th problem. So question says the vertices of a quadrilateral are minus 4. Okay, so there's a quadrilateral. So let me draw a rough quadrilateral for you. So this is my rough quadrilateral. Okay, so the vertices of the quadrilateral are given to be minus 4, 2. Another vertex is given to be 2, 6. Another vertex is given to be 8, 5. And the last one is given to be 9, minus 7. Okay, so using slopes, show that the midpoints of the sides of the quadrilateral form a parallelogram. Means you first find the midpoints. Okay, so after finding the midpoints, what you are going to do is you will join them. Okay, so after joining, okay, suppose if I call the midpoint to be, for example, PQRS, okay, then we need to show that PQRS, this is your parallelogram. That means this and this will be parallel, okay, and this will be parallel. So that's what we need to show in this particular question. Okay, so let me call this to be A, or let me call this to be A, B, C, D. Okay, or you can call this as P, Q, R, S. Okay, so you will follow this diagram. Okay, so you can make this diagram in your copy as well. Okay, so we have this question number 13. So let the given points be. Okay, so let the given points be. So let me write the names as A, is minus 4, 2, B, that is 2, 6, C, this is 8, 5, and last point, that is D, is 9, minus 7. Okay, so as we need to find the midpoints, okay, we'll make use of midpoint formula here. Okay, so let P, Q, R and S be the midpoints of, okay, so P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of AD, right? AD respectively. Okay, so we have seen what are the midpoints. So let us find the coordinates of each, alright, because in order to show that this is a parallelogram, we need to find the slope of each line, okay, and in order to find the slope of each side, we need the coordinates of the vertex, okay. So therefore the coordinate of P is, okay, so for P let us make use of midpoint formula. So midpoint formula says x1 plus x2 whole divided by 2, that is minus 4 plus 2 whole divided by 2, yes, and y1 plus y2 whole divided by 2, that is, how much is this? Let us see. So minus 4 plus 2 is minus 2, so minus 2 divided by 2 is minus 1, comma, so 2 plus 6 is 8, so 8 by 2 is 4. So the coordinate of P is minus 1 comma 4, okay, so this is minus 1 comma 4, okay. So similarly let's find the coordinate of Q, okay. So the coordinate of Q is, okay, so Q is the midpoint of B and C, so x1 plus x2, that is 2 plus 8 by 2, comma 6 plus 5 by 2, which is equals to how much? That is, okay, so this is 10 by 2 is 5, yes, okay, and how much is this? So this is equals to 11 by 2. Okay, so this is the coordinate of your Q. So this is 5 comma 11 by 2. Okay, so similarly let us find the coordinate of R. Okay, so similarly we have the coordinate of R. Okay, so this turns out to be 17 by 2 minus 1. Okay, and the coordinate of S turns out to be this much. Okay, so I have marked the coordinates in the diagram as well. Alright, so again I don't have space here, so let me erase this again so that we'll be able to find the slope of each side. Okay, so that is PQ, QR, RS and SP. So we are going to find the slope of each side. Okay, so therefore let me start with PQ. Okay, so we have M of PQ. So we have y2 minus y1. So this is my x1 y1, this is my x2 y2. So y2 is 11 by 2 minus y1 is 4 divided by x2. x2 is 5 minus of minus 1. So 5 minus 1. Okay, so let us calculate this. So this is 11 by 2. Okay, so 11 minus 8 by 2 whole divided by, this is 6, right? So this is my 6. So this will be equals to 11 by, so this 3, 2 into 6, this 2 gets cancelled, so this is 1 by 4. I hope you will be able to calculate this. Okay, I am not going to show, this is a basic thing, so it has to be 1 by 4. Okay, now similarly let us calculate what is slope of QR. So slope of QR turns out to be, this is my x1 y1, this is my x2 y2. Okay, so y2 is minus 1 minus y1 is 11 by 2 divided by x2 minus x1. Okay, so let us again calculate in the same manner. So this turns out to be minus 2 minus 11 2 by 17 minus 10 by 2, this 2 gets cancelled, so this is minus 13 by 7. Okay, so the slope of QR is turning out to be minus 13 by 7. Okay, similarly, let us find the slope of SR or RS. So M of RS. So RS turns out to be this is my x1 y1, this is your x2 y2. Okay, so y2 minus y1, y2 minus y1 divided by x2. X2 is, I'm sorry, x2 is 5 by 2. So x2 is 5 by 2 minus x1. x1 is 17 by 2. So again simplify this, minus into minus is plus, so this will be minus 5 plus 2 by 2 whole divided by so 2 is there, 5 minus 17, so 2 and 2 gets cancelled, so this is minus 3. Yes, so minus 3 by this is minus 12. Yes, okay, so minus and minus gets cancelled, so 3 1s are 3, 3 4s are 12, so this is equals to 1 by 4, right? So the slope of PQ and RS, right? So PQ and RS both are turning out to be equal. That means PQ and RS, they are parallel to each other, as we can clearly see from the figure as well. Okay, now the last one is we need to find the slope of SP, okay, or PS. So slope of SP will be equals to, call this as x1 y1, call this as x2 y2. Okay, so y2 minus y1. So 4 minus of minus 5 by 2 divided by x2. x2 is minus 1 minus 5 by 2. Alright, so let us quickly calculate this. This is 8 plus 5 by 2 whole divided by, so this is minus 2 minus 5 by 2. Okay, so this and this gets cancelled, so this is 8 plus 5 is 13 and this is minus 7, so minus 13 by 7, as we can clearly see from here. Okay, so as M of PQ is equals to M of RS, right? So M of RS, this means PQ is parallel to RS. Yes, okay, and we have M of QR. M of QR is equals to M of SP. So this implies that QR and SP are parallel. All right, so from these two we clearly see that PQRS is a parallelogram. All right, so that's what you will write at last. So hence PQRS is a parallelogram. All right, so you may pause the video to note down. Okay, now I'll give you one condition here. So there is a straight line here. Okay, so there's a straight line. Now I'm taking 3 points on this straight line. So this is one point, this is another point, this is another point. Okay, so can I say that these 3 points are collinear? Yes, definitely they are collinear. Now you all know the meaning of collinearity. If the given points lie in a same straight line, then the points are known as collinear points. So basically these 3 yellow dots are collinear points for this particular straight line. Okay, now here let me give coordinate here. So this is my x1 y1, this is my x2 y2, and this is my x3 y3. Okay, and how many slopes does a straight line have? It will always have one slope. It won't have multiple slopes. Okay, so one straight line means only one slope. That means if I use these 2 points, that is x1 y1 and x2 y2, I'll be able to find the slope of this straight line. Suppose, for example, if the slope is m here, okay, now forget about this x1 y1. Now let us make use of x2 y2 and x3 y3. Using these 2 coordinates also I'll be able to find the slope, right? Okay, and what will be the slope out here? As I said, there will be only one slope possible. So I already know the slope is m. So that's why this will also turn out to be m here. Okay, so that means here I am going to talk about the very important property, and the property is collinearity of 3 points. Again, you need to write this in your diary. So collinearity of 3 points. Okay, so the 3 points are x1 y1, x2 y2 and x3 y3. Okay, so let me write this as A, B and C. Okay, so basically 3 points will be collinear, that's A, B and C will be collinear if the slope of AB, okay, and the slope of BC both will be same. Alright, so the condition is slope of AB must be equals to slope of BC. So if this happens, then A, B and C are collinear. Okay, so the 3 points are A, B and C. Alright, so you may note down this in your diary. Alright, so with this, let us see question number 7. Okay, I'll do 2 questions for you based on collinearity. So there are some problems in your exercise, you will have a look at them by yourself. Okay, so let me take question number 7. So question number 7 says, using slopes find the value of x so that the points 6, -1, 5, 0 and x, 3 are collinear. Okay, so the given points are, this is question number 7. So the given points are, okay, so let me name it A, 6, -1, B, 5, 0 and C, that is x, 3. Okay, so these are the 3 points which are collinear. Okay, so the given points are, okay, which are, okay, so the given points are A, B and C and they are collinear. Okay, so they are collinear, that's what the question says. So therefore, as we know, the condition for collinearity is m of AB must be equals to m of BC. Okay, so therefore m of AB is equals to m of BC out here. Alright, so let us see what is m of AB. So slope of AB, so we have y2 minus y1, so 0 minus of -1 divided by x2, that is 5 minus x1, that is 6. So this will be equal to, let us see what is slope of BC. So this is my x1 y1, this is my x2 y2. Okay, so y2 minus y1, that is 3 minus 0 divided by x2, that is x2 minus x1. Alright, so from here we will calculate the value of x. So this is equals to, so this is minus into minus is plus 1, right, divided by this is minus 1 equals to 3 into x minus 5. Okay, so from here let's do cross multiplication. So we have x minus 5 into 1 is x minus 5 equals to minus 1 into 3 is minus 3. Take this 5 over there, so you have x equals to, this is 5 minus 3. So therefore what is the value of x? The value of x turns out to be 2. So you may pause the video to note down. Okay, so let me take the last question for you, that is question number 14. So in question number 14, there are 3 points given to you and they are given to be collinear. So using that condition, I have to again prove one of the equation that is given to you. Okay, as you can see in your screen as well. Okay, so let me write, the given points are, okay, so the points are A, that is x1, y1, B, that is x2, y2 and P, that is h, k. Okay, and again they are collinear. Okay, so what do we need to prove? We need to prove that h minus x1 into y2 minus y1 is equals to k minus y1 into x2 minus x1. Okay, so that's what we need to prove here again. So as we know that A, B and P, they are collinear. Okay, so we have, this means that the slope of AB, okay, so slope of AB must be equals to slope of BC, right? Isn't it? So see here carefully. So we have A, B and C. Okay, so be careful out here. So you can write here BC. Okay, so let us see first what is happening here. So if I do that, then we have, let us see what is slope of AB. So this is my y2 minus y1 by x2 minus x1. Okay, so in our whatever we need to prove, do we have y2 minus y1 and x2 minus x1? Yes, I can see that y2 minus y1 is also there, x2 minus x1 is also there. Okay, now, okay, so this is fine for me. I don't have any problem out here. Now let's see what is m of BC. Okay, slope of BC. So let us use BP here, right? Not C, it is BP. So let us make use of B and P out here. Okay, so this is my x1 y1, this is my x2 y2. So the formula says y2 minus y1, so k minus y2 divided by x2 minus x1, that is h minus x2, right? Okay, but do we have h minus x2 here? We don't have h minus x2, instead we have h minus x1, isn't it? So that's why in this case I am going to show you one more thing. Here we said that, okay, so this is my P, right? Slope of AB and slope of BP, both are going to be same. Okay, but instead of B, if I use A and P, again I will get the slope of same straight line, isn't it? Are you understanding? Okay, so I am using A and P, but still I will get the slope of the same line. So that's why here instead of BP I am going to write AP. Okay, why you will understand here. So suppose if I use A and P, then my formula becomes y2 minus y1. Okay, so here it comes y1, okay, whole divided by x2 minus x1. Remember I am using A and P. Okay, x2 minus x1. x1 is x1 itself out here. Okay, now if you go to this, then we have h minus x1, right? And similarly we have k minus y1 also. Okay, so here basically we will make use of AB and AP instead of BP. Alright, so you have to be very careful when you do this. Okay, so let us do the cross multiplication. So from here this and this gets multiplied, so we have h into x1, okay, into y2 minus y1 equals to, again this 2 gets multiplied, so we have k minus y1 into x2 minus x1. Okay, so this is what we need to prove. Okay, so we have successfully proved it. Alright, so you may pause the video to note down. So with this we close this particular exercise, that is exercise 11.4, and it's your job to go through the solved examples and try a few more sums from your exercise. Alright, with this we close for the day. Thank you very much.